On your second page, you'll see example 11. It says in 1 through 4 on the previous page, highlight all boxes that contain the outermost electron. So you'll need a highlighter. Hopefully I've remembered and provided one. If not, you'll need to pause it now and remind me to give you a highlighter. So I've got mine selected. On number 1, the outermost electrons are going to be identified. They're going to be in the highest numbered boxes. So here I have some electrons in 1, I have some electrons in 2, and that's it. So my highest level, the one I'm going to highlight here, is just the 2s. In example 2, I have the electrons in 1, but I have them in the 2s and 2p. The 2 is the highest number, that's the energy level number. So I'm going to highlight the s and the p boxes. On number 3, I've got 1, I've got 2s, but I also have some electrons in the 3s and the 3p. So I'm going to highlight both the 3s and the 3p because they're the highest number. And in number 4, the highest number here is 3s, so I'm going to highlight those. 12 says, in 5 through 8, highlight all the boxes that contain the outermost electrons. So pause it, take a second, and make sure you can highlight the outermost electrons in 5 through 8. Hopefully you did that. In carbon, that should be the 2s and 2p. In fluorine, the 2s and 2p. In silicon, the 3s and 3p. And in chromium, this was probably the tricky one, it is 4s. Notice that some electrons go back into the third energy level after the 4s fills, but the highest one that fills is the 4s. So only highlight this box. These are going back into the third energy level, and you have some in the fourth. Okay, example 13 says, how many unpaired electrons are in the following elements? So you go back and you look, and an unpaired electron is simply, it's a single arrow in the box there. So in lithium, I have one unpaired electron, this one right here. This is a pair, this one is unpaired. In oxygen, there are 2 unpaired electrons right there. So oxygen has 2. In phosphorus, we see 3 electrons that are unpaired. And in magnesium, there are 0. All of those electrons are paired up. There are no single or unpaired electrons. So now you pause it and do the same thing for the 5 through 8. All right, in the carbon, you should have said 2. In the fluorine, you should have said 1. In the silicon, there are 2. And in the chromium, there are 4. So if you have any questions, you're not sure how to do that, you pause it right now and ask me for some help. Example 15 says, of all 8 elements, which one has the most unpaired electrons? Well, that's easy to find there since we have them all written out here. It is chromium with 4 unpaired electrons. 16 and 17 says, what would the orbital diagram, and that's what we're drawing here with our little arrows, look like? And we have some ions here. We have charges. So we still have lithium. Lithium, before it is a charged ion, has 3 electrons. And electrons, remember, are negative. So the fact that this is positive 1 means it has lost one of its electrons. So you kind of do the opposite operation. So we're going to subtract 1. And so what we're going to place for the lithium is now, for the lithium positive 1, is now 2 electrons. So I'm going to do that one right here by the number 16. So 2 electrons, those will just go in the 1s. So that's what lithium with a positive 1 charge looks like. Now oxygen, it starts out with 8 before any are lost or gained. But here it's gained 2 electrons. That's why it has a negative 2 charge. So again, kind of think about it as doing the opposite operation. It's negative 2, so I'm going to add 2 electrons. And so for the oxygen ion there that's negative 2, I'm going to place 10 electrons. So this is oxygen, negative 2. So I've got 2 4, 5, 6, 7, 8, 9, 10. Now you try it, pause, and you try it for carbon -4 and vanadium +3. And what you should have for carbon -4 is 6 + 4 or 10 electrons, so it should look just like the oxygen. It should have 10. And vanadium has 23, but you're going to subtract 3 from that, so it will have 20. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we have one more question. It says, what is incorrect about each of the following? There is a mistake with each one. On number 20, the mistake is right here. We have both arrows pointing up, and they are representing opposite spins, so they should be pointing in opposite directions in the same orbital space through the same box. Okay, here our mistake is right here. We should not pair them up. This P, you have to separate them first and then pair them up if there's more than 3. So that's the mistake there. Okay. I don't see, I'm looking for the mistake here. Oh, I see. This didn't get filled before they put electrons here. So they left an electron out there. One of these should be over there. And on the last one, we don't have them going opposite directions.